Good morning, learners. Today I will take you through the answers of Maths Evening Test number 1, which covered algebra. The test which was written on the 29th of September 2025. So the main aim is to just take through the answers and also clarify the misconceptions that we see when we mark grade 12 papers. My name is Hadile Mampolo. Without any much ado, let me take you through the paper. Let me share my screen. Excuse me. Now, I'll just take you through this so that at the end, when you write the final paper, at least in question 1, you can get the minimum of 15 marks. So just know that if you got the minimum of 15 marks, it means you got the minimum of 10% of paper 1. Let's quickly look into question 1. Your quadratic has already been factorized. The other side is 0. One of the mistakes that most learners are making, you will find that the quadratic is factorized and the other side is 0, and then the person will clear the brackets factorized and factorized wrongly. So if it's factorized and the other side is 0, just find the values of x. The values of x in this case should be 0 and -4. Question 2. Another mistake that we see learners making is dividing both sides by x. If you have a question like this one, you have 3x squared plus 5x. Learners, you can divide both sides if there's a common numerical, the common number, or there's a common factor of a number. If there's a common factor of a variable, you don't divide by the variable that you're solving. Unlike here, you cannot say you divide both sides by x. If you have x squared and x on the other side, take this one, the 5x to the left, and then take out x as a common factor. Then you say x equals to 0. So x equals to 0 or x is equals to 5/3. So don't divide by the variable. Number 3, again, is a quadratic, is factorized, and the other side is 0. If the other side is 0, you just find the values of x. So the x will be 2/3, or x will be -5. Here there's no need to clear the brackets because the other side is 0. What is required of you would be just finding the value of x. Unlike question 3, this has been factorized, but the other side is not 0, it's -45. In this case, you have to clear the brackets, take -45 to the left, divide both sides throughout by what? By negative. Remember, when you are solving for variable, or when you want to factorize, the first thing, if your coefficient of x squared is negative, divide throughout by negative. But it does not mean that if you didn't divide by negative, you lose marks. So you can just use a quadratic formula. Learners, I just want to take you through this. I'm aware that there are those of you who are still struggling with factorization. If you are that person, let me just quickly take you through this. If you are that person who still struggle with factorization. You just do this. Let me, oh, sorry. Just want to show you what you do in case you're struggling with factorization. Learners, there's no rule which says you only use a quadratic formula when the roots are irrational. Now, if you are that person who struggles with factorization, let me just give you the time-saving method. After you have written your equation in a standard form, just write down your, even if you don't write it down on your answer sheet, just write down the quadratic formula, quickly substitute A, B, and C. Let's quickly do that. Here we'll have -3, -3, and also here you say -3, say -3 squared, then you say 4 into 2, which is our A, and then our C is -44. Let's put -44 here. Let's put -44, and then you put 2A. Like I said, even if you don't write on your answer sheet, if you write on the separate sheet, it's fine. Then you you punch it on your calculator. Now, the reason why I know that some of you know how to factorize using the calculator and all that. But remember, even if you use a calculator, there's still method that you have to memorize. The reason why I prefer the quadratic formula method, it is because it's given in the formula sheet. You can't say you forgot it. Now, you substitute, then you punch on the calculator. Now, the answers that you get on your calculators, in other words, when you do, you leave the space, you leave the space for the factors. Then the answers you get on your calculator, calculator are the ones that you put here. So then you leave the space here for factors, meaning that you'll substitute, you put quadratic formula on your calculator. In the first one, you can put plus. Then you get the answer. You'll find that your answer is 11/2. So, and then you quickly go to your calculator, move your cursor where the positive is on your quadratic formula. You cancel plus and put minus. Then you get the answer, you get these x values. Then, after you got them, remember x values are the ones that you get when you punch on your calculator. Then now, if the first value is 11/2, the denominator of the fraction is the coefficient of x, then you'll say 2x. The denominator is the coefficient of x. Now, if you got positive 11/2, then on your factors you'll have a negative. So it means on your factors you will put the opposite side. If you got positive answer, then there will be negative. Then the coefficient of x will be the denominator of that answer, of the denominator of the fraction. So then 11 will be here. Then on the other side here, there's no, on -4, there's no denominator, then it will just be 1x. Then it's -4, then it will be +4. Then you'll have, then here you're factorized without wasting any time. Then you have this. Then you got your answer. But if you find that your x values, the x values you got on the calculator, are in simplest sort form, it means the roots are irrational. It means now you must write that the quadratic formula on your answer sheet as it is. You copy it from the formula sheet, then you substitute before, because you get the marks for substitution and the answers. But if the answers are rational, then you don't have to write down the quadratic formula. Then you'll just leave the space for factors. Then the answers you get on the calculators, you write them here. Then from there you factorize with reference to the x values that you got. So no one of you will get wrong answer as far as factorization is concerned. Like I'm saying, most of you know how to do that using a calculator, but you may forget the steps. If you forget the steps, the quadratic formula method is the way to go, because now quadratic formula is given in the formula sheet. You can't say you forgot it. Now, question 5. Let's quickly go to question 5. Let's put this nicely. Now, question 5. You see question 5 here? Here you have your equation, is not in a standard form. We don't have 0 on the other side. Then, now if remember, in a quadratic formula, you only use a quadratic formula, or you factorize directly if the other side is 0. In this case, it's not 0. Clear the brackets. Minus 3 times x minus 3x minus 3 times negative 2 is positive 6. Then you take them to the left. Now your equation now is in a standard form. Now you can see that by me looking, when you substitute as I showed you in question 4, the answer will be in a set form. If your answer is in a set form, the values of x are in a set form, it means the roots are irrational. It means now you have to show your quadratic formula. You copy quadratic formula on your formula sheet, then you substitute, then you get the answer. Remember, the first answer is when this here is positive, and then the other one would be when here is what? Negative. Then you get the answers. Like I said, if your answer is in a set form, it means that quadratic formula must be written, and then you must also substitute. You must owe your substitution if the roots are irrational. Excuse me. Number 6. Number 6, you can see also here is not in a set form. It means now, remember when you remove square on one side, you put square root on the other side. Cube, you put cube root. Exponent of 4, you put the 4th root. But remember, if your exponent was the even number, you say plus or minus. So in this case, because it's a square, you say plus or minus the square root of 49. You have plus or minus 7. Then say 3x minus 1 equals to 7, or 3x minus 1 will be equals to negative 7. Then it will be 3x equals to 8. Then x will be 8 over 3. It will be 3x will be minus 6. X will be minus 2. Alternatively, you can first clear the brackets, FOIL, then you get 9x squared minus 6 plus 9 equals to 49. Then you get 49 to the left-hand side. It will be negative 48. Then you factorize using a quadratic formula method if you are struggling to factorize directly. But in this case, the answers will not be irrational. They will be rational. So there's no need to write quadratic formula. What you'll do, you leave the space for factors, substitute on your quadratic formula in the calculator, then you'll get 8 over 3 and minus 2, Then for factors, remember I told you that if your answer, let me just change it here. So if you have 8 over 3, it means 3 will be 3 will be the coefficient of x. 8 will be here. 8 will be here. Now, like I told you that in bracket we'll have the opposite sign. Remember here the answer is positive 8 over 3. Then you'll have negative. Here is negative 2. Remember, if the denominator is 1, then it's 1x here. Then it will be plus 2x. Then you'll also save time in terms of doing the factorization, because the calculator will do the job for you, and you'll have a formula sheet, that what you call the quadratic formula on your formula sheet. The next one will be how to find if your exponent is a fraction. Always you know that if the exponent of the middle term is the half of the half of the first term, you always know that this is a quadratic formula. So we know that when you factorize, you divide the coefficient of the first term of the exponent of the first term by 2. If you have 2 and 2, then you can still use quadratic formula, substitute 3, 11, and 8. Obviously, we get negative 8 over 3, and then have negative 1. So, you just substitute a quadratic formula as you did in the previous questions. Excuse me. So then you say x to the power half will be negative 8 over 3, or x to the power half will be negative 1. So we know that when you remove half, exponent of half on one side, you put its multiplicative inverse on the right, which is 2. Then you square both sides. Then you get 64 over 9 and 1. Now, if you can substitute these values on the original equation, they will not satisfy the original equation, because if you substitute them, left hand side will not be equal to the right hand side. The reason why we substitute, we know that when we deal with square root, we must check whether the values satisfy the original equation. Then if they don't, then you reject them. So remember, x to the power half is the same as the square root. You can see in the alternative method, you can just change x to the power half to be the square root of x. Then we know that when it's a square root, then you have to isolate the square root, square both sides, then you get the same answer. You can see that when you substitute these two values on the original equation, they will not satisfy it. It means left hand side will not be equal to the right hand side. So no solution in this case. So you reject both the values because they don't satisfy the original equation. Like even number 8 is a square root. First step, you isolate the square root. You take negative 2x to the other side, then you have 2x plus 4, square both sides. Then you get the answer, and then simplify it, write it in a standard form. Remember, there's a mark for writing this in a correct standard form. So make sure that your standard form is correct. Then you can use a quadratic formula again. Leave the space for this. When you use a quadratic formula, you'll get negative 47 over 4 and 1. As I said, when you leave this, the space for this, because if you jump this, you may lose marks. So make sure that this part where you factorize, you write it. But remember, use quadratic formula, get the two answers, which is negative 47 over 4, and you'll get 1. So then you go back here after you have used a calculator. And remember, you leave the space here, you get these answers, then you factorize. 4 is a denominator, then it's a coefficient of x, then it's minus, then you say plus, the 47 is here, here it is negative, is positive 1, then in bracket is negative 1. Then you get the answer. Remember, when you deal with square roots, you must substitute those values to the original equation to check whether they satisfy the original equation. Now, here 1 satisfies the original equation, but negative 47 over 4 does not satisfy the original equation. That is why we reject it. Satisfy. So it does not. So this one does not satisfy the original equation. Let's just write it. There was misspell. It does not satisfy. It does not satisfy the original equation. It does not satisfy the original equation. Only 1 satisfies the original equation, because when you substitute 1, left hand side will be equals to the right hand side. But when you substitute negative 47 over 4, left hand side is not equals to the right hand side. That is why we say it does not satisfy the original equation. It means the only x value will be 1. Then C is the correct option. Now, question 9. Learners, I just want to emphasize this. We know that most of you use the diagram to interpret the solution of the inequality. So just know that if your inequality sign, if your inequality sign is less than, if inequality sign is less than, this is the sign of less than, so you know that you'll just write something like this. You'll know that this will be like this if the inequality sign is less than, provided the coefficient of x in both the brackets is positive. So again, if inequality sign is greater than, here you write like this: if it's less than, then small number on the left and the bigger number on the right. Then if inequality sign is greater, then you must know that x is less than the small number or greater than the big number, provided the coefficients of x are positive. So then you say or if it's greater, you say and if it's less than, but provided the coefficient of x is positive in brackets. Now look at, when we look at this one, this is factorized already, is 0, it's already in a standard form, but when you check in this bracket, the coefficient of x is negative. So what you do, you'll divide the terms only in the bracket where the coefficient of x is negative. You divide them by negative, meaning here it was negative 2x is positive 2x. Here it was positive, this is negative. But remember, if you divide that by negative, the inequality sign will change from less than to greater than. So like I told you, if it's greater than, then x is less than the small number or greater than the bigger number. So the small number in this case is -3, the bigger number is half. Then you'll say x is less than -3 or x is greater than half, because the inequality sign changed from less than to greater than. So if the coefficient was positive, then you will say minus 3 is less than x, x is less than half. So if you write this way, small number on the left, the greater number on the right. But if it's greater than, x will be less than the small number or greater than the big number. Because it's greater here, you'll say x is less than minus 3 or x is greater than half. Number 10, if you check in this case, we have x equal to this, then here you can see that you have a common factor of 3 to the power x. Say 3 to the power x into, here we left with x, here we left with 3. Now, we know that if you have 3 to the power x, you are solving for x. X will be 3 to the power x will be greater than 0 for all values of x. Meaning that even if x here is negative 1, 3 to the power negative 1 is positive 1 over 3. So x, 3 to the power x will be greater than 0 for all values of x. Then it means that x will just be less than negative 3. It means this will not change. Why is it not changing? Because now for this one, will not have the one value of x, but we'll say 3 to the power x will be positive for all values of x. Even if x can be 0, 3 to the power 0 is positive 1. If x is negative 2, 3 to the power negative 2 is positive 1 over 9. So 3 to the power x will be positive for all values of x. Then x will just be less than negative 3 in this case. Now, let's look into exponential equations. Let's start with the simplest one. I know that in grade 12 they are not going to give you a simple thing like this, where you'll just be given a question like this. We know that question like this is asked in grade 10, but you can have a question where part of it will be like this. So if you have like this, you first divide by 5 over 2. Now, normally you know that if the bases are not the same, you can't use that method where you use the prime factors. Let me quickly take you through this. If the prime factors are not the same, you just go to your Casio calculator. If you're using Casio, then you see the log key, this key. If you look at this log key with 2 brackets, this is the only way you can find x if you are solving exponential equation where the bases cannot be the same. So meaning that on this shaded bracket you put the base, and then on this other bracket you put the number on the other side. Now check here, the base here is 7, then you put 7 here, and then you put 5 over 2 this side. So this is the way when the bases cannot be the same, then the answer will be 0.47. But remember, if the bases can be the same, let's use the method like if you want to change 1024 to the prime factors, you say 1024, then say equal sign, then from there you press shift, then you press this key, then you find the prime factors. But in that one, 5 over 2 cannot be changed to 7 to the power something. So if the bases cannot be the same, you use the log which is below the on key. Then here you put the base, which is 7 in this case, then you put the other number, which is 5 over 2 in this case. Then x would be 4, sorry, it would be 0,47. Question 12, you are solving for x, and then you can see that you have only two terms which are multiplied because you are solving for x. Anything with x must be on one side, anything without x must be on the other side. But because they are multiplied, you find the multiplicative inverse. Here, 25, you multiply, you divide, it becomes a denominator. Here, 5 to the power x becomes a denominator. So everything with x must be taken to the left. Then, then this will be 3 over 5 all to the power x. Then you make the basis to be the same. Remember, 3 to the power 3 is 27. 5 to the power 3 is also 27. Then, then you'll say x equals to 3. But if you don't want to change prime factors to prime factors, you can do as we did on this on the calculator here. The base will be the 1, which is the base of x. This will be the number on the other side. In other words, let me show you. If you don't want to change this to prime factors, you can just go to the log, which is below the on key. You'll say x. Let me just copy it. You say x equals to, then you press the log below the on key. Then in this case, you'll have something like this. This is your log. Then remember here, you put the base. The base here is 3 over 5. Then you say 3 over 5 because it will be 3 over 5 all to the exponent x. Then let's put 3 over 5 here. Let's put 3 over 5 here. Then you move the cursor. Here you put 27 over 125. You put 27 over 125. If you don't want to change the number into prime factors, then you get all the marks. This will be 125. And then you punch it on your calculator, press the log, this below the on key, then you say 3 over 5, and then you say 27 over 125. I was just pressing on the calculator, then you'll see that you'll get the same answer as 3. So let me just put this one as the alternative method. I know that most of you are used to changing to prime factors, it's still fine. So I'm just saying, if you don't want to change the prime factors, you can use the log. They say, oh, let me cancel this. So obviously, in this case, you'll have this one. Let me do it. Then we'll say you'll have something like this. Let me cancel the x here. Let's have x. This will have, here you'll have 1 over 3. Let's quickly do that. Say 1 over 3. Sorry, 3 over 5. I mean to say 3 over 5. It's 3 over 5. Then you'll have this. Sorry, you have 3 over 5 all to the power x. Say all to the power x. All to the power x. Then you put this on the log. That's, like I said, the base, you put it here. The number on the other side, you put it here. Then you get the answer as 3. It means the correct option in this case will be a B. Number 13, 1 over 25 to the power x. Remember, if you have in the terms you have the power with the same basis and same exponents, so it's not a trinomial, then it's where you take out the common factor. You can see that when you change 125 to the power x, it will be 5 to the power 3x, because 5 to the power 3 is 125. So if you check, here you have a common factor. This is your common factor. This one will be your common factor. 3 to the power x is a common factor because it's here, also here, and also here. But first you'll break this into common factors. So if you check, when you break into common factors, then you hear this one. Let me break this, the middle one, into the prime factors, into the factors. Then you break it down. I mean to say, then you break it down. Then when you break it down, then here you'll have 5 to the power -1, which is 1 over 5. Hence you have 6 over 5 in the next step. Hence you'll have 6 over 5 in the next step. Then here you'll have 1 over 5. 1 over 5 is 5 to the power -1. Then when you break this one down, but we still have 3 terms. Remember, in maths, numbers which are multiplies, we take them as 1 term. Then it means on the left hand side we have 3 terms. Now here, this it will be 5 to the power 2x, because 25 is 5 squared. Then when you add them, it will be 3x. So in these 3 terms, we have a common factor of 5 to the power 3x. Then you take it out as a common factor. Here will be left with 1, 6 over 5, and -7. Then when you take this one, the multiplicative inverse of -24 over 5, it will be -5 over 24. Then let's move this here. Then the answer will be 1 over 125, which is 5 to the power -3. Then you drop the basis because the exponents, because the bases are the same. Then you have 3x to the power 3x will be -3, then x will be -1. So remember, when in the terms you have the powers with same basis and same exponents, then you take out the common factor. Now let's look into number 14. In number 14, if you change this, you can see that here, when you break this down, you have half to the power 2x, but here you have half to the power x. Whenever you have the exponent that is half of the one in the other term, you must know that it's a trinomial, because here is 5, here is also 5, but here is 2x, here is x. Then x is half of 2x. So you know that in this case you have a trinomial. You let 5 to the power x to be k. Then you have it means where there's 5 to the power x, you are going to put what k, but you have square here because there's a 2. We didn't let 5 to the power 2x to be k. We have 5 to the power x to the power k. Sorry, you let 5 to the power x to be equals to k. That's why where this 5 to the power x we put k. The square is still here. This 25 is this one. Here is 124. Here 5 to the power x is substituted by k. You say -5. Then you factorize using quadratic formula as I showed in the previous questions. Then you have k is equals to 1 over 25, or k equals to -25, -5. Now, but you are not solving for k, you are solving for x. Then you return 5 to the power x, you substitute it where there's k. But remember, when you solve the exponential equations, the the equation can only be valid if the bases have same signs. Here the signs are not the same, then you reject it. There's no solution in this one. Here you change 5 to the power minus 2 to be 1 over 25 to be 5 to the power negative 2. Or if you don't want to change it, you can just use the log to say x equals to log 1 over 25 base 5. You'll get the same answer. Then x will be negative 2, then C will be the correct option in this case. Number 15, if, again, you can see that you have exponential equation, but in this case, like I said, if you see that the x is half of the other, is a trinomial, even if you have the same base and then the exponent, one of the exponent is positive, the other one is negative, you must also know that it's still a trinomial. In this way, you see that when you break it down, you'll have 1 over 2x, here you'll have negative 1 over 2x. Now, to make the exponents to be the same, remember when you move a power from numerator to denominator or vice versa, exponent changes the sign. You take this one down so that the exponent can change sign. So that is why now is 2 to the power 1 over 2x. Now that is the same here and here. You let 2 to the power half x to be a k. Now where there is k for 2 to the power half x, you put k. You have 4k. Here you have 4 over 1 over 2, 1 over k equals to, then you take it to the left because it will be a trinomial. Our LCD is 2k. Then you multiply throughout by 2k. Then at the end you have 8k squared would be 63k. Excuse me. You have 63k from this one, then minus 8. Because k cancel k here, we'll have minus 8. You factorize. Can use a quadratic formula as I've shown in the previous questions. Then k will be 1 over 8 or k will be minus 8. Then we are not solving for k, we are solving for x. Then you return 2 to the power half x as where there's k. You substitute it where there's k. Then you make the basis to be the same. Then here you reject it because, like I told you, when you solve exponential equations, if the bases have different signs, have opposite signs, then you reject it. There's no solution here. Then here half x, because if bases are the same, exponents are equal. Now half x is equal to negative 3, then x will be negative 6. And then again here, you have a simultaneous equation where one equation is in exponential form. You change it from exponential form to you change it from from exponential form to linear form. So what you do first, you take this 4 to the power y you divide to be this side. You make the basis to be the same. You know that when you divide powers of the same basis, you subtract the exponent. Then you'll have 2 to the power x minus 2y equals to 2 to the power 5. The bases are the same. Then you drop the exponents. Then this will change to be in a linear form. Then x will be 2y plus 5. Then you substitute 1 into 2. You get the answer. You simplify. Then you write your excuse me. Then you write your equation in a standard form. You can either factorize directly, and then you can use the quadratic formula as I've shown you in the previous questions. You'll find that y is equals to negative 43 over 7, or y equals to minus 7. then you substitute this to one of the equations, preferably the simplest one, and then the simplest one in this case is a linear, which says x equals to 2y plus 5. Then you substitute to get the values of x. Let's look into this one. Let's just cut this one here. Here it says if p equals to 25, the square root of 25 minus 4x squared over x minus 1. The values of x for which p will be real. Remember, the number inside the square root can be real if it's greater or equals to 0. Remember, the square root of 0 is a 0. The square root of positive number is a positive number. But there's no square root of a negative number. So for this to be real, is when the number inside the square root is greater or equals to 0, or also when the denominator is real. Remember, in this case, the denominator can only be real if x is not equals to 1. Because if x is 1, this will be undefined. Then you'll say, well, 25 minus 4x squared is greater or equals to 0. But remember, when you divide by negative, inequality sign will change. If it was greater than, it will be less or equals to, because you divided by negative. Because we divided by negative. Remember, when you divide 4x squared by negative, it will be positive. 25 by negative is negative 25. So greater or equal sign will be less or equals to. Like I told you, if it's less, you write this x in between, small number on the left, the bigger number on the right. Then it means x will be between minus 5 over 2 and 5 over 2. But if it was greater, we'll say x is less than the small number, which it will be x will be less than negative 5 over 2, or x greater than 5 over 2. But here, because it changed to be less, then x is between negative 5 over 2 and 5 over 2. But in this case, 1, which should not be part of the solution, is between these two values. So it means x is between minus 5 over 2 and 5 over 2, but it cannot be 2, otherwise we'll have undefined. So it means in this case, your answer will be negative 5 over 2 and 5 over 2, but x should not be equals to 1. It means D will be the correct option. It's none of the above, because yes, B, we have x is between minus 5 over 2 and 5 over 2, but we didn't reject x equals to 5 over 2. But if in this B we said x is between minus 5 over 2 and 5 over 2, but x is not equals to 1, then it could have been the correct answer. So it means for the fact that we didn't reject x equals to 1, then none of A, B, and C are correct. So none of the above is the solution in this case, because in B we didn't reject x equals to 1. So none of the above is correct. Okay, number 18, if 2x squared plus px plus 2x plus 2 is equals to minus p, the values of p for which the roots will be unequal will be, remember, first you are going to write your equation in a standard form, take p to the other side, then you'll have p, which is if you take it to the other side. I think here I jumped the step. Let me write the step because it must be shown. Remember, the equation must be in a standard form what do? You first take everything to the left so that the equation equals to 0. When equation equals to 0, when you take p to the other side, then you'll have this. P will come to this side, plus, then we say equals to 0. Remember, you don't substitute to the discriminant if your equation is not in a standard form. Now that it's in a standard form, we can say discriminant equals to b squared minus 4ac. Then we're again, the next step here, the next step, you'll write the equation in the form of ax squared plus bx plus c. Now, when you take x as a common factor, your b will be p plus 2, and your c will also be p plus 2. Now, then you substitute b, you substitute this, you'll have p squared minus plus 4p plus 4 minus 8p minus 16. Then you write it in a simplest form. Then you'll have p squared minus 8p minus 12. Then when you factorize, you'll have p minus 6 into p plus 2. But we know that for roots to be unequal, discriminant must be a positive number. So, but if I was saying real, you say greater or equals to, because when discriminant equals to 0, the roots are real, but discriminant will be 0. But now here we say when they are unequal. They can only be unequal when the discriminant is greater than 0. It's greater than 0. Like I told you, when it's greater, you write the critical values, then whatever you're solving will be less than the small number or greater than the bigger number. There's no need to write that because that graph does not have a mark. Because it's greater than here, then p will be less than minus 2, or p will be greater than 6. Number 9. In number 9, you say if f of x is equals to minus 2x squared plus 5x plus p equals to, and g of x equals to minus 3x plus 2, the values of p for which f and g will intersect once are. Now, first what you do, you equate the two. You'll get your equation in a standard form. Learners, I want to bring this to your attention. If you are given the two graphs and say, find the values of p or whatever variable that is given, when they say find the value for which the two graphs will not intersect, it's like they are saying no solution. You will say discriminant is less than 0. If they say for which the two graphs will intersect once, it's like when they say the roots will be equal, then you will say discriminant equals to 0. If they say for which the two graphs will intersect can be once or twice, we'll say greater or equals to. If they say for which the two graphs will intersect twice, it's like when they say the roots will be unequal, then you say the discriminant is greater than 0. Not intersecting is when discriminant is less than 0. Intersecting once is when you say the discriminant equals to 0. Intersect, you say greater or equals to. Intersect twice, you say a discriminant is greater than 0. But first you equate the two graphs, you write one equation in a standard form. But in this case, because you said intersect once, then you substitute the values to the discriminant where b will be 8, and then when a will be minus 2, c will be p minus 2, then you will say here discriminant is equals to 0. Why is it equals to 0? Because we said intersecting once. But if we're saying intersecting twice, we'll say greater than. If we say not intersecting, you say less than. Then I just want to to mark this for your attention. But in this case, we say where the graphs will intersect once. It's like when to say when the roots are equal. That is why discriminant in this case would be equals to 0. Then you solve for P. The last one, in exam, they can say, they give you something like this with very big exponents. They say without using a calculator. And in this case, if they say without using a calculator, if you use a calculator, the answer will be irrational, and then the marker will see that you use the calculator. But now, in this case, the reason why I asked, I didn't just say simplify this. I say the simplified common fraction of this, the denominator of the simplified fraction in this case is what? I wanted you to do this without using a calculator so that it gives you a fraction, and then the fraction, now I want only the denominator of the fraction. But if you just use a calculator, then it will not give you that denominator. Now in this case, you make the basis to be the same, it's 7 to the power of this, and then we know that this kind of question, you make the exponent, the smaller exponent will be your common denominator. You see that after you simplify this, the smaller exponent in this case will be 79,998. So here when you take it out, you will have 7 to the power 1, because 79999 minus this one will be 1. Here minus this, this one will be 2. Here minus this one will be 3. So here you took it as it is, then here's 1. Now they cancel. Then when you write it in a simplest form, here will remain with 7 plus 49. Here we'll have 343 minus 1. It will be 56 over 342. Then when you write it in a simplified form, then denominator will be 171. Then the correct answer will be 171. Leonard, thank you for listening, and thank you for those who have written the test. Remember, most of this you did this in grade 11, from grade 10, but I want us to take you through this to ensure that at least in question 1 you get 15 marks, not less than that. If you get 15 marks, it means you already got the 10% of the paper. And algebra is the basic for all the math topics, even paper 2. If you can do well in question 1, there's the high likelihood that you'll do well in all the questions. And learners, you worked hard to be where you are. It's not the time to give up. And how you performed in prelim on the previous exams does not define you. Now is the time that you must fire all the cylinders, and then write the other tests, and then the test will help you. You'll gauge yourself as to how far you are in terms of preparation, in terms of readiness, as far as the final exam is concerned. Thank you for watching, and thank you for listening, boys and girls. All the best. See you in the next test.